Hi guys, so in today's lesson we're going to be looking at the laws of logarithm, and we're going to start with the first law of logarithm, and we have log p cube is b, and that's going to be equals to log p base b plus log q base b. So we see that this is a multiplication going on here, and by the time they separate up together we're having addition here. So that's basically the first law of logarithm. And let's see how this plays out in an example. So let's see log, let's see log 3 times 5 base 10. So that's going to give us log 3 base 10 plus log 5 base 10. So that's how the law plays out in an example. Let's take another example. Log 7 times 6 base 3. Okay, so that's going to be log 7 base 3 plus log 6 base 3. So this is how the first law of logarithm plays out. Then we have the second law of logarithm, which has to do with division. So we have log p divided by q base b, and that becomes log p base b. Then you have the minus here, then log q base b. So let's see how this plays out in an example. So we have log, so let's say we have log 7 over 3 base 3, and so that's going to give us log 7 base 3 minus, because of the division, then log 3 base 3. Then let's see another example. Let's see log 9 over 4 base 5, and so we're going to have log 9 base 5 minus log 4 base 5. So let me just give you this last example and you have to work this out yourself. Let's say log 5 over 2, log 5 over 2 base 2, and so what's that going to be? Think. Yes, obviously you're right. That's going to be log 5 base 2 minus log 2 base 2. So that's basically how to apply the second law of logarithm. Then you have the third law of logarithm. Then you have log p raised to the power of n base b, and that's going to give us n log p base b. So what they basically did was take this index and took it to the back of the log. So let's see an example. Let's say we have log, let's see log 7 squared base 3. And so we're going to bring these 2 to the back. That's what the law says. We're going to have 2 log 7 base 3. Let's see another example. Let's see log 36 base 2. So log 36 base 2 can you can write log 36 base 2 as log 6 to the power of 2 base 2, because 6 to the power of 2 is actually 36. So I'm going to take this 2 to the back, and then I can write this as 2 log 6 base 2. And let me give you this last example for you to guess what answer that would be. Let's say log 16 base 2. What do you think your answer is going to be? Absolutely, that's going to be log 4 squared, which is 16 base 2. And that's going to give you, bring this 2 to the back, and so you have 2 log 4 base 2. Yes, that's the fourth law. Log b base b is equals to 1. So when the base and the number is actually the same, then we say that it's equals to 1. So how did they get this? Let me explain how they got this law. So basically what that means is, if I transform this to index form, that's going to be b to the power of 1. I'm going to get b is equal to b to the power of 1. And of course, b raised to the power of 1 is b. So that was this law stands. Okay. Then let's see an example. Let's say we have log 5 base 5. So what's that? Log 5 base 5 is actually 1. And what about log 10 base 10? 10 base 10 is also 1. So when the number at the base is actually the same, the result is 1. So let's see this example. Let's say log 25 base 5. What do you think this answer is going to be? Okay. Right. So we're going to apply the knowledge we've gotten from the previous laws. I'm going to write this as log 5 base 5. That's 5 squared is actually 25. So I'm going to bring this to the back of that, and then I'm going to get 2 log 5 base 5. And what's 2 log 5 base 5? That's 2 log 5 base 5 is 1, and so 2 times 1 is actually 2. So that's our answer. And so we're looking at the fifth law of logarithm, and that's basically log 1 base b is actually equals to 0. And so how does this law come to be? Is this law true or not? Let's check. Let's turn that to index form. So you have 1 becomes b to the power of 0, and of course anything raised to the power of 0 is 1. So this law is correct. Then let's see an example. Let's see log 1 base 3. So what's log 1 base 3? According to this law, it says that when log 1 has any base, the answer is equals to 0. What about log 1 base 5? That's equals to 0 also. So what about if you have log 6 raised to the power 0 5? What should you have? This is basically simple as well. So I could basically just say that 6 raised to the power of 0 is 1. So 1 base 5, and that's basically equals to 0. Then we have the sixth law, which has to do with the change of base. How do you change numbers in different bases from one base to the other. So we're saying base log p base b, and if I were to change that to log base c, we just say log p, which is going to be at the denominator, base c are required base. Let's see an example to actually understand this better. Let's see log let's see log 5 base 10, and let's convert that to base 3, logarithm in base 3. So I'm going to have log 5 base 3 over, then this 10, that's going to be log 10 base 3. That's how to change base. Let's have another example. Log let's see log 7 base 3, and let's convert that to base 10. So basically that's going to be log 7 base 10 are required base over log 3 base 10. Let's say one more example. Log 5 base 2. Let's convert that to log in base 7. That's going to give us log 5 base 7 over log 2 base 7. And so that's how to convert to different base.